Welcome to Black Mesa Labs. This video demonstrates how to set up the SUMP2 logic analyzer on an icoBoard FPGA board for the Raspberry Pi to make a dedicated benchtop 100 megasample per second 32 channel logic analyzer. The original SUMP2 logic analyzer targeted the $22 USB iStick from Lattice as a USB logic analyzer peripheral for Windows PCs. Traditional FPGA logic analyzers are limited by external SRAM clock frequencies and bit widths. SUMP2 is unique as a logic analyzer as it is a portable Verilog IP component that utilizes hardware run-length encoding compression for storing fast and wide samples to internal FPGA block RAMs. This version of SUMP2 targets the icoBoard for Raspberry Pi, a Lattice ICE40HX8K breakout board that interfaces via SPI to the Raspberry Pi 2x20 header. The icoBoard may be purchased from Trends Electronic. 4 8-bit 2x5 PMOD connectors on the icoBoard provide for 32 3.3 volt LVCMOS inputs to SUMP2 for 100 megasample per second data acquisition. For software performance reasons, only the Raspberry Pi Model 3 or faster is recommended for SUMP2. The first step for configuration of SUMP2 on icoBoard and Pi is to download the pre-configured Jessie Lite Raspbian image from Black Mesa Labs. On Windows, Win32 Disk Imager may be used to transfer the 2 GB image file to a 2 GB or larger micro SD card. This image file is a customized boot image for automatically installing and executing embedded Python software on the Pi, either from local micro SD or a USB drive. This OS image file is non-SUMP2 specific and was also used for the HAB-1 balloon flight to 100,000 feet in May of 2016. On completion of image burning, boot the Pi with the micro SD and a default Hello World prompt should result. The SUMP2 software is now copied to a USB flash drive. The tarball appdata.tgz contains both the FPGA bitstream and the Python software for SUMP2. The text file installsoftware.txt instructs the Black Mesa Lab Jessie Lite image to detar and copy the files to the local SD card of the Pi. On boot up, the Pi should now automatically launch the SUMP2 software. On first boot, it is necessary to right-click the main menu and select System Load FPGA to program the FPGA PROM with the SUMP2 firmware. After the PROM is programmed, it is necessary to select System Reboot to restart the Pi. With the Pi rebooted, you may now select a source trigger and acquire samples using SUMP2. In this final section of the video, I will demonstrate the basic operation of the software and the importance of the different mouse regions for activating different menus. This is a quick demonstration of the user interface. There are 3 regions of mouse operation for the SUMP2 GUI. There is the signal name region where you can left click to select a signal and then right click to do something like assign a trigger to it or also rename the signal. There is the waveform area, which is the main menu. You can right click here and then you can do something like acquire. Here are the acquired samples. If you by default it zooms in a bit after the acquisition to minimize the amount of rendering required. To view all samples, you can right click and say zoom full. And then down here are the 2 cursors where you can left click and drag each cursor to the region of interest, and you can click on edges and then it will automatically snap to those edges. If you want to speed up the SUMP user interface, you can crop the acquired data by right-clicking and selecting cursors and crop to cursors. And this effectively tosses all the data outside that bound region. The last region is the scroll on the bottom. So if I zoom in a bit here, now if I move the mouse down to the bottom and I use the scroll wheel, I can pan left and right in time. And if I move the mouse back up, I can right click and say zoom out, zoom full, and zoom to regions. Some other options are you can save the current screenshot as a PNG, a JPEG bitmap, raw text hex data, and also as a VCD Verilog value change dump file. Exporting VCD does take a while, as there are the dataset has to be decompressed and then recompressed in VCD format. So if I wanted to save PNG, I would click Save PNG, and then it's going to save it to wherever the SUMP2 executable resides, either on the local micro SD card or else on an external flash drive. One way to acquire more samples is to hide signals prior to acquisition, and that effectively removes the events from the RLE compression algorithm. And to hide signals, you can double click on their names, and you can see they turn off. And now if I reacquire, I'll click off this as well, I should be able to acquire more samples. Acquire RLE. I'll do it in full. Cursors, bring the cursors to view, and then I will zoom in. And when you're all done with the acquisition, to gracefully shut down the Pi, right click, select System, and shut down. This concludes this video. I hope you find SUMP2 for icoBoard to be a useful open source debugging tool for your electronic workbench. Thank you for visiting Black Mesa Labs.